So in this section, we're going to take a look at our trigonometric functions. So our main trig functions are sine, cosine, and tangent. There'll be three more, but they relate to these initial three, so we'll talk about those in a little bit. But for now, we'll just focus on sine, cosine, and tangent. So something we need to think about is the fact that we're dealing with functions, which functions themselves we have a lot of practice with through algebra. So just as a little refresher of what a function is, a function deals with input and output. So in algebra, we saw some notation like f of x equals y. Now there's kind of three pieces to this notation. There's f, which is just the name of the function. It didn't hold a numeric value, it wasn't just a letter. It told us about some relationship that we were going to use. So f was just a name of the function. And then we had some input, which with the functions that we worked with, that was often our x coordinate that we were plugging in. And then the output for the function was often our y coordinate that we were looking for. So in our algebra classes, we dealt with functions where you input an x coordinate, get out a y coordinate, following this operation that f told us to follow. When we look at trig functions, it's the same idea, but what's going to change is this relationship of what our input is and what our output is. So trigonometric functions relate an angle of a right triangle to ratios of two side lengths. So what that means is that the input for our trigonometric function is going to be some angle, and this angle can be given in degrees or radians. So we'll talk about the difference between the two. In this video for now, we're just kind of dealing with the geometric space. So with that, we're going to be working with degree measurements. But as we saw in the previous videos, we could switch to radians since they're equivalent. So the angle is going to be the input for our function, and then the output for our function is going to be a ratio of two side lengths. So with our right triangle, we have three side lengths that we're working with, and the trig function that we're using will tell us which two to pair up, and making this ratio, what will go in the numerator, what will go in the denominator. So that will be our output. So with these functions, input of an angle, output of this ratio of side lengths. So since we're going to be looking at three functions, and then like I said, even three more, but we'll pause on those, we want to memorize these ratios that are coming through. And a great phrase to use for memorization is SOHCAHTOA. Now I realize we haven't even looked at the ratios yet, so we'll come back to that. But I just like to put it there at the top of the page so you can refer back to it easily. If you've taken trigonometry before, then you've probably heard SOHCAHTOA before. So we'll refer to that to kind of help us memorize these functions with the ratios that we're looking at. So when we deal with these trigonometric functions, the input is going to be an angle measurement. So when we're looking at our right triangle, there's going to be two options for this angle measurement. Here, we're looking at this angle T, but we could have easily been over here at this other angle that isn't defined, and that's fine. What we won't have is we won't be standing at the right angle itself. So either T or this other angle up here. So since we're going to be focusing on this angle T, this is kind of like where I'm standing in terms of location within this triangle. So making names, or not making names, but labeling the names of these side lengths, well, the hypotenuse, it doesn't matter where I'm standing in the triangle. I'll say this a lot, the hypotenuse is the hypotenuse. It isn't really depending on anything else. It doesn't matter where you stand in there. It's just the longest side length that's opposite the 90-degree angle. So without any other information, just if I drew a quick right triangle, you can label the hypotenuse. But without more information, I don't know which side I want to label the opposite side or the adjacent side. That's where we need to think about where are we located within this triangle. So I was saying about kind of standing, is that I kind of imagine a person standing at that angle, and the side length that's labeled opposite versus adjacent is dependent on kind of its location to that person. So the opposite side length doesn't touch the angle that we're focused on. It's on the opposite side of the triangle. So that's where we label this opposite. Adjacent just means touching, which it is touching this side with the angle that we're focused on. So that's where this side length is called adjacent. So if you imagine we did decide to actually stand over at this angle, the hypotenuse would stay the same, but opposite and adjacent would change. What was adjacent would now be considered our opposite side, and then what we labeled our opposite side would now be our adjacent side. But we're not going to look at that angle. We're going to focus on this angle T. So when we work with our trigonometric functions and this right triangle, we need to think about the angle that we're focused on, and with that labeling the three sides of the triangle: opposite, adjacent, and hypotenuse, because these trig functions are going to make ratios of two of those sets. All right, so let's look at these trig functions. So the first function we're going to look at is sine. So how I would read this notation right here on the left-hand side, out loud, I would say that as sine of t. So it's kind of like how we read f of x. The parentheses are just showing us what the input for our function is. So like how I would say f of x, this is sine of t. And then we see that sine of t is equal to the opposite side length divided by the hypotenuse side length. So this is where we're seeing our ratio of two side lengths from the triangle. So in terms of relating this to that function notation that we saw up above, that sin at the beginning there, sine, is just telling us the name of the function, telling us that we're working with a sine function, and the t there is the input for this function. And that input, when we're working with sine, cosine, tangent, specifically is an angle measurement. As we see in the picture up above here, we're seeing the input for our function is this angle measurement t. And then the output is everything on this right-hand side here, which is a ratio of two side lengths. So what we're getting here is this relationship. We have this new function that we're calling sine. And the idea is that if we see we're working with a sine function and we're focusing on this angle t, then from standing at that point in that triangle, we're going to take the length of the side that's opposite of it divided by the hypotenuse. So that's our function sine. Cosine. So again, I would read this as cosine of t. What's really changing here is the name of our function, which means we're using a different function. It operates similarly to sine in that we have this input of an angle. So it's like if I go to my triangle, I'm still standing right there. What changes is that by changing the name of the function to cosine, now I take the adjacent side length divided by the hypotenuse. So what I would do for my calculation is take this side length that's adjacent divided by the hypotenuse. So it changes the pairing of side lengths that we're going to use. And then our third one here is tangent. So this would be tangent of t. And with this one, again, input of that angle t, and the ratio is going to be taking the opposite over adjacent. So we have these three trig functions. So we have these three different names. If we input the same thing into all three of those functions, which in this case we're inputting this measurement of angle t into all of them, what changes is which two side lengths we pair up to take the ratio. So what we need to memorize is which pairing goes with which functions. So sine is always opposite over hypotenuse. Cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. And this is where SOHCAHTOA comes in. It helps us remember if we're working with sine, it's opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So SOHCAHTOA can help a lot. You'll hear me probably say it a lot in the lecture videos and any videos that I make, trying to make sure I remember the ratios correctly, because it also gives you the order of numerator over denominator. SOHCAHTOA. It'll help a lot. So let's see this in action. So we're going to look at this triangle right here. And something that's key right now, so this is right triangle trigonometry, so we have to have a right angle in there. So we're going to look at sine, cosine, tangent of angle A and angle B. So let's focus on angle A right now. So I'm just going to mark that we're at angle A, which means this is the focus of my trig functions, is the input of whatever that measurement is for angle A. So with that, I want to label the side lengths. So the hypotenuse, I could always do that without even knowing which angle I'm focused on. So that 19 is going to be the hypotenuse. And then from there, what I'm going to do is label opposite and adjacent. So I can see that 11 is opposite. And that side length x is touching that angle A, so that would be adjacent. So sine, cosine, tangent. What I'm going to do is make a little note, and I'll kind of go through SOHCAHTOA here. So sine is going to take opposite over hypotenuse, so, and then cosine, so CAH, adjacent over hypotenuse. And then tangent, TOA, so tangent is opposite over adjacent. So that sets up my ratio. So sine of A, so sine of A, I'm going to take the length of the opposite side, which we're seeing is 11, compared to that angle A, and the hypotenuse, which is 19. So here's where we can see we'd have this input of an angle, and the output is this ratio of side lengths. Cosine of A, so we're taking our adjacent side length, which is that unknown x, over the hypotenuse, which is 19. I was just thinking we could solve for x here. I'm going to leave it as x just so we can see where it's coming from, but if we needed to know the exact value of x, that would just be our Pythagorean theorem. So the fact that 19 squared is equal to x squared plus 11 squared. I said I wasn't going to do it, but I'm going to do it. I started it now. I need to finish. 19 squared minus 11 squared is 240. So x is going to be about, let's do 15.49. So we solve for that. I'll go ahead and mark that there. Making this adjacent over hypotenuse, I could leave it like that, x over 19. This would also be the same thing as 15.49 over 19. And we can reduce that into a decimal. It kind of depends on what they want as a solution. Here we just said fill in the blank, so it's kind of weird to have a decimal within a fraction, so I'm just going to take that one step further. Said I was going to skip all of that, but it's good to see. So this would be a 0.8153. So it didn't say to solve for x, it didn't say to do that, so you could leave it as this x over 19. But we are capable of solving for it because of that Pythagorean theorem. All right, and then for tangent, opposite over adjacent. So opposite is 11, adjacent is x, and if I went ahead and filled in what we solved for, we would have 11 over 15.49, which is 0.71. All right, so with these, standing at angle A and had opposite and adjacent. So now let's look at what if we were standing at angle B. So if we're at angle B, so we're over here now, it's going to change. It's our opposite and adjacent sides. Hypotenuse stays exactly the same. What I'm going to do is delete where I wrote adjacent, delete where I wrote opposite, because now it's going to change where opposite is now x. And adjacent is now that side length of 11. So, going through sine, cosine, tangent again, now we're taking sine of B and taking opposite over hypotenuse, so that would be x over 19, or that 15.49 over 19, which simplified to that 0.8153. Cosine of B, so our adjacent over hypotenuse. Well, now adjacent is that 11 over the hypotenuse of 19. We could leave it like that. And then tangent. So tangent of B is opposite over adjacent, so we'll have x over 11, which would be that 15.49 over 11, which would reduce down to, 1.41. All right, so that's how we can use our trig functions with a right triangle. It's just a matter of recognizing what angle is the input and then making that kind of your point of view of where opposite and adjacent is, and then using SOHCAHTOA or those kind of relationships with the ratios to solve the side lengths. All right. So what I was mentioning before is that there are 3 more trig functions, so cosecant, secant, and cotangent. But how we get to just kind of throw these in is that these are called the reciprocal trigonometric functions. So reciprocal really just means switch the numerator and denominator. So what that means is that cosecant lines up with sine. It's the reciprocal of sine, so where sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Cosine lines up with secant, so where cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And tangent is opposite over adjacent, so cotangent is adjacent over opposite. So really, it still just comes down to SOHCAHTOA, but it's just recognizing that the numerator and denominator switch. The trickiest piece of this can be remembering which function goes with which. In past classes, it's usually easy to remember that tangent goes with cotangent. That makes a lot of sense. Those go together. If you know tangent, TOA, opposite over adjacent, then cotangent, just flip them. What's trickier are these two. Knowing that sine goes with cosecant and cosine goes with secant. It sometimes works kind of opposite of what we think it should do. One way that I kind of remember it is I think of the S and C's kind of pair up with each other. So sine and cosecant would go together, cosine and secant would go together. So kind of those pairings of letters. Another thing that I think about, since we often think of sine, cosine, tangent in that order of sine, cosine, tangent, we get kind of used to thinking of it in that form. In the reciprocal functions, we go cosecant, secant, cotangent. So I think of it as writing out the cosecant function there. Those are different ways to remember it, but what's really important is sine, cosine, tangent, and then it's just a matter of pairing up what their reciprocal functions are. Okay, so let's do another example here with our new functions working. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's just going through SOHCAHTOA there. Cotangent, I know, is the flip of tangent. So if tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. Secant goes with cosine. Again, I think of that as, I know this is a reciprocal function, and since it's S, it would go with C. I basically don't want to pair letters is what I'm thinking there. So secant goes with cosine. So cosine's adjacent over hypotenuse, so secant would be hypotenuse over adjacent. And then cosecant, so that starts with C, so that would go with sine since that starts with S. So opposite over hypotenuse, just flip it for hypotenuse over adjacent. All right, so let's start with these ones that are focusing on A. So I'm going to think about being here at angle A, which means C is our hypotenuse, A is going to be opposite, and then B would be adjacent. So for sine of A, I want opposite over hypotenuse, so that's going to be little a over little c, opposite over hypotenuse. Tangent of A, I want opposite over adjacent, so that would be little a over little b. And then secant of A, I want to take the hypotenuse, which is C, over adjacent, which is B. And then our next three are going to deal with angle B. So over here, I'm going to change my opposite and adjacent. So now B is opposite and A is adjacent. So cosine of B, I want adjacent over hypotenuse. Cotangent of B, adjacent over opposite. And then cosecant of B is the hypotenuse of C over adjacent, which is A. So just figuring out those ratios, but really we just need to know sine, cosine, tangent. We can get cosecant, secant, cotangent by flipping those relationships.